Hello students, today we will study scalar and vector field. So first of all, we need to understand what is field. Field is a region of space in which physical quantity is well defined at all the points at given instant of time. In this region of space, a physical quantity possesses different values at different points. It means that a region of space where the physical quantity is well defined is known as a field. Suppose x, y, z axes are space coordinates, and this is the yellow shaded region of space which contains many points. Suppose this is a point A at which physical quantity mass is well defined and the value of mass is m1 at A. Suppose this is a point B at which the value of physical quantity is m2. So at different points the physical quantity possesses different values. So this shaded region or this yellow region is simply known as field. So the examples of field are electric field, magnetic field, gravitational field, etc. Basically, field has two types. Field can be classified into two types: scalar field and vector field. So what is scalar field? Okay, scalar field means the region of space in which scalar quantity is well defined. Okay, so a scalar field is the region of space in which scalar quantity is well defined at all the points at given instant of time. And in this region of space, scalar quantity possesses different values at different points. Okay, so well defined means scalar field in which scalar quantity is well defined means the scalar quantity is single value, continuous and definite. It means at a particular point scalar quantity has single value and this scalar quantity has a continuous values inside the region but definite. So suppose phi is the scalar function of xyz, okay, because scalar quantity is inside the space, so the space coordinates are xyz. So therefore phi is the scalar function of xyz. So phi can be written as phi is equal to phi xyz, and these xyz are space coordinates. And suppose this is the region of space, and inside this region of space scalar quantity is well defined. Suppose this is the point A at which the scalar function is phi1 and scalar quantity is phi1. Suppose this is the point B where the scalar quantity is phi2. It means inside this region at every point the value of scalar quantity is different. It means at every point possess different values of scalar quantity at different points, and it is continuous inside this region and definite. So this region is known as, because inside this region scalar quantity is defined, so this region is known as scalar field. Now we will see the examples of scalar field. Okay, examples of scalar field. So what are the examples of scalar field? For example, when the variation of temperature at various points, when one rod is heated, metal rod is heated from one end, okay, so one is hot end and other is cold end. So variation of temperature takes place inside that rod, okay, and temperature is a scalar quantity. So variation of temperature, it means temperature field is created inside that rod. So that temperature field is called scalar field because temperature is scalar quantity. So we will understand this by one animation. Suppose this is a rod, cylindrical rod, okay, this red end is hot end. Suppose it is heated from this end, so this red end is hot end and other end is cold end. Okay, suppose the temperature of cold end is T1 and temperature of hot end is T2. It means that T2 is greater than T1. Okay, but temperature is distributed from hot end to cold end. Okay, this temperature is distributed. So at every point, suppose at every point the value of temperature is vary by certain Kelvin, certain millikelvin. Okay, so this temperature, so inside this rod the temperature gradient is created or temperature field is created. Okay, so this is nothing but the scalar field. So this is also called scalar temperature field. So this is the example of scalar field. We'll see the second example. What is second example? Second example, suppose electrical potential is vary at various points when body is charged. Okay, so this is also the example of scalar potential field. If surface of charged body have same values of scalar potential field, if suppose the potential field is uniform, okay, so that surface is called equipotential surface. Suppose this is the positive charge, okay, again there are the positive charge, and this positive charge are uniformly distributed, okay, and the value of positive charge are equal. So this surface, it means that have same value of scalar potential at every point. So this surface is nothing but equipotential surface. So what is equipotential surface? If a charge body have same value of scalar potential field, this is called equipotential surface. So equipotential surface is also the example of scalar field. So these are the example of scalar field. Now we will see vector field. Similarly, vector field can be defined as, okay, vector field can be defined as a region of space in which vector quantity is well defined at all the points at given instant of time. So in this region of space, vector quantity possesses different values as different points. So well defined means we know that well defined means the vector quantity is single value, because vector has both magnitude and direction. So therefore vector quantity is single value means both in both magnitude and direction, vector quantity is continuous and definite. So suppose V is the vector function. So V is the vector function inside the space. So V is equal to V can be denoted by V is equal to V vector x, y, z, because V is the vector function. So we will understand pictorially. Suppose this is space coordinates x, y, z, space coordinate xs, x, y, z, and this is suppose the region of space. So inside this region of space, various vector quantities are there. Okay, so vector quantities can be represented by the point and arrow. Arrow represent the direction of that vector quantity or that physical quantity. So suppose this is point A at which the vector quantity or vector function is defined by v1, and suppose at point B the vector quantity is defined by v2. So this vector quantity is different inside this region at various points. So this vector quantity is single value at a particular point, but this vector quantity is continuous inside this region, okay, and definite. So this region is nothing but the vector field. So this region is called vector field. Okay, now we will see the examples of vector field. So first well known example is electric dipole, because electric dipole consists of positive and negative charge separated by the finite distance. So because of that positive and negative charge, electric field is created. So electric field has direction. Electric field has direction from positive to negative. So that's why it is a vector field. Suppose this is positive charge and this is negative charge. So electric lines of force travels from positive to negative charge. Okay, so the direction of electric field is can be represented by this arrow from positive to negative. Okay, because the charges or electric lines of forces, okay, originated from positive and ends on negative charge. So here we see that the electric lines of forces approaches towards the negative charge, and electric lines of forces make outward, okay, the electric lines of forces in outward direction from the positive charge. Okay, so somewhere here is positive charge, electric lines of forces travels from positive to negative charge. So direction here, the direction of electric field, okay, and here positive to negative charge. So direction of electric field is this, and here is the direction of electric field is this. So see this, so electric field has a direction. Okay, if electric field is created from positive and negative charge, it means created by the dipole, it has a direction. Okay, so therefore it is the example of vector field. Now second the magnetic field. Okay, the magnetic field around a bar magnetic field has also a direction, so it is also the example of vector field. Suppose this is a bar magnet, and we know that it is north pole and it is south pole. So magnetic lines of force travels from north to south pole, originated from north and ends on south pole. So see, this is the direction of magnetic lines of force, originated from north and ends on south. Similarly, here in downward position, the direction of the magnetic lines of force from north to south. So this white arrow represents the direction of magnetic lines of force. So the field direction is also from north to south pole. So this is the magnetic field direction, can be represented by magnetic field vector. So the magnetic field vector has a direction and magnetic field has direction from north to south pole. Therefore the magnetic field around a bare magnet is the example of vector field. Okay, again the famous example of vector field is gravitational field. Okay, suppose gravitational field is also a vector field. Suppose this is a sun, this is a earth, and this is a moon. Okay, this is earth and this is a moon. So in between earth and moon there is a strong gravitational field directed towards earth, because earth is heavier object than moon. So gravitational field is directed towards earth. So this arrow represent the gravitational field in between earth and moon. So this gravitational field has a direction, therefore the gravitational field is also a vector field. So these are the examples of vector fields. So today we have studied what is field, what is scalar field and vector fields and their example. Thank you very much.